Hello and welcome to my class. I am Professor Adesh Kumar Srivastav, Associate Professor, School of Management, BBD University. Today, I'll be discussing database architecture. This is a university database, for example, you can say, where we have the table like student, course, section, grade report, etc. We will talk about schema architecture. Three of four important characteristics of the database approach are self-describing of database, that is a schema, insulation between program and data, support of multiple views of the data. Three schema architecture. It was proposed to help achieve and visualize these characteristics. Three schema architecture, it defines a schema at three levels. We are talking about three-tier architecture, in which first is internal schema. It is at the internal level to describe physical storage structure and access paths. For example, indices. Conceptual schema at the conceptual level to describe the structure and constraint for the whole database for a community of users. External schemas at the external level to describe the various user views. This is three-tier schema architecture, a figure for your understanding. You are seeing here it is external level, that is external view for different users. First is this is stored database, which is comes under internal schema. So that is internal schema. After that, it comes conceptual schema. Conceptual schema is at conceptual level. This is at the middle level, and thereafter there is external schema or schema. You can say external view or external level. So these are three level and three schema architecture. Centralized DBMS architecture, a centralized DBMS in which all the DBMS functionality, application program, execution and user interface processing were carried out on a single machine. This is physical centralized architecture for your understanding. These are terminals, the display monitor in a network, and this is the middle level layer, the layer of software, maybe DBMS, compilers, terminal display control, application program and text editor. This is software layer, you can say middle layer. Thereafter operating system, and operating system, the system bus, controller, these are controllers, and memory, disk, CPU. So this is all hardware and firmware. It's a physical centralized architecture. Example of physical centralized architecture. Now we come to basic client server architecture. Actually, when we talk about this three-tier architecture, we always talk about basic client server architecture. The client server architecture was developed to deal with computer environment in which a large number of PCs, workstation, file server, etc. A client in this framework is typically a user machine that provides user interface capabilities and local processing. A server is a system containing both hardware and software that can provide services to the client machines. Now we'll talk about logical two-tier client server architecture. So this is a figure about logical two-tier client server architecture, where we have a layer of these are the client in a network, and this is server. This is print server, this is file server, and this one is DBMS server. So there are two layers only. One is of server and another is of client. So this is a logical two-tier client server architecture in a network. In two-tier architecture, why it is called two-tier? This is called two-tier architecture because the software components are distributed over two systems, client and server. The emergence of the web changed the role of client and server, leading to the three-tier architecture. Actually, first two-tier architecture was existing, but the emergence of the web and the advancement technologies have changed the roles of client and server, which led to the invention of three-tier architecture. So what is three tier? We discussed earlier. The intermediate layer or middle layer is sometimes called the application server or web server. In three tier architecture, it can enhance security. Database server only accessible via middle tier. Clients cannot directly access to the database server. So a middle layer works as a bridge between external layer and internal layer. That's why it provides a security, and it can enhance security. This is a three-tier client-server architecture model in which the first one is database server, database management system, right? Application server or web server, where we have application programs or web pages, and then there's client GUI interface or web interface. So these are the three layers, right? This is a three-layer architecture and the example of three-tier architecture. The presentation layer displays information to the user. The business logic layer handles intermediate rules and constraints before data is passed up to the user or down to the DBMS. If the bottom layer is split into two layers, a web server and a database server, then it is a four-tier architecture. It is possible up to n tier. Now, we talk about these three levels of abstraction. Physical or internal level. The lowest level of abstraction describes how data are actually stored. It describes complex low-level data structures in detail. So what we have in the physical or internal level, we have the complex low-level data structures in detail, that is given there at that particular level. Then we come to the middle level or logical or conceptual level. It describes what data are stored in the database and what relationship exists among those data. So the middle layer or the conceptual layer or the logical layer, whatever you call, it talks about the database stored and their relationships. It describes the entire database in terms of relativity, simpler structures. So this is described in logical or conceptual level. Now we talk about view or external level, the highest level of abstraction which describes only a part of the database. User's view of the database. This level describes that part of the database that is relevant to each user. So this is the highest level of abstraction. It describes only a part of a database, and it describes only that part of database which is relevant to the user's view or a user's perspective. So this is the highest level of abstraction. So these are the three levels of abstraction which are present in three-tier architecture. So logical or conceptual level, it describes what data are stored in the database and what relationship exists among those data. We discussed earlier. Now we'll see it in detail. It describes the entire database in terms of relatively simple structures. The implementation of these simple structures at this level may involve complex physical level structures. Users of the logical level need not be aware of this complexity. Database administrators who decide what information to keep in database use the logical level of abstraction. So the database administrator use the logical level of abstraction. Again, this is a view, we have seen it. So this is view of external, this is logical view, and this is physical level view. And these are levels of abstraction as we have seen earlier also. View 1, view 2, view 3. These may be three different users which may be viewing the different way, in a different way. So many views, single conceptual, logical schema and physical schema. Views describe how users see the data. So as I told you, they may be seeing the data in a different perspective, different way. Conceptual schema defines logical structure. This middle level, this conceptual schema actually defines the logical structure, how the data is logically related to each other, what are the relationship amongst the data. Now the physical schema describes the file and indexes used. The physical schema describes files and indices used in the database, and we all know what is a schema. A schema is nothing but the set of rules. So schemas are defined using DDL, that is data definition language. Data is modified or queried using data manipulation language. So ANSI Spark 3-tier architecture, the proposal for standard terminology and general architecture group for DBS produced in 1971 by DBTG Database Task Group. This is just a historical background of this particular architecture. Appointed by Conference on DBS and Languages, that is CODASIL, DBTG recognized the need for a two-tier architecture with the system view schema or users view sub-schema. ANSI, that is American National Standard Institute, and SPARC, that is Standard Planning and Requirement Committee, produced similar terminology and architecture in 1975. This was ANSI X3 SPARC in 1975. So ANSI SPARC recognized the need for a three-tier architecture, and from there the three-tier architecture evolved. So we have seen this. This is the figure what we were seeing since a long time in this lecture. So external level is the user's view level, and the middle level is conceptual level or logical level, and the internal level is physical level, where we talk about physical schema. In the middle level we talk about conceptual schema, right? So in other terms we can also say that in middle level layer there is physical data independence, and at the external level there is logical data independence. We'll talk about data independence in the next lecture. Now this is the figure levels of DBMS architecture diagram in a graphic. External level layout for end users. So this view 1, this user is viewing something different. This is view 2, this user is seeing something different. And this is view 3, this user is seeing something different. So all are seeing the different views from the same database. And the conceptual level, that is middle level, where the conceptual schema is developed. So this is the middle level. And after that the physical layer, where physical schema is there, and this is database, that is the internal level. So this was the detail about levels of DBMS architecture and schema and three-tier architecture. Right now we have understood all this three-tier architecture up till now, but now we will see the same thing with the help of graphics. Now let us see the three-tier architecture with the help of graphics.
DBMS architecture refers to the design of database and its related elements. It describes the connectivity of database, the application program used to access the database, and the user who manipulates the data. Based on the design, it can be divided into 4 types: 1-tier, 2-tier, 3-tier, and n-tier architecture. In case of 1-tier architecture, the DBMS is stored on user's system and can be directly used using an interface. It is normally used by database designers and programmers. So, let us imagine that you store and manipulate your data on your desktop or laptop using MySQL. You are using 1-tier architecture. In 2-tier architecture, the application program runs on the client side. The database is stored on the server. An interface called ODBC connects the application program and the database on the server. ODBC stands for Object Database Connectivity. It is a translation layer used to access the database and the user interface application. Some common examples of 2-tier architecture are the database servers, like Oracle, Sybase, and Microsoft SQL Server. Users interact with the data using client applications or GUI, such as Visual Basic, Visual C++, or Access. In 3-tier architecture, the application program runs on the client side, and database is stored on the server. However, unlike 2-tier, an intermediate layer, called application layer, is stored on a separate server. This layer stores the programs that access the database from database server. The application tier acts as a mediator that presents the data to the user in a required form. What most of us don't know is that even though the 3 layers work together to create a 3-tier architecture, each of the layer can be operated and managed individually. Another type of architecture is n-tier. case of n-tier or multi-tier architecture, the database, application and presentation layers are stored on 3 or more different tiers. It typically contains 3 tiers: data tier, middle tier, and presentation tier. This kind of architecture is mostly used in web applications, like e-commerce. In most cases, n-tier architecture begins as a 3-tier model. An increase in the amount of data might lead to situations where organizations might store interrelated databases on more than one server. This is known as distributed database and is managed by Distributed Database Management System. However, as a learner of DBMS, we will use single or one-tier architecture and store and manipulate our data on the same system.
So we have seen with the help of graphics that how this three-tier architecture works. So thank you all for watching and listening patiently my lecture of DBMS architecture. Thank you all for your patience, and you are always invited for all the queries. If you have any doubt, you can contact to me online and offline always. Thank you very much.